Hi everyone, we're going to analyze the rational function. I'm going to call this h of x on this one, of x cubed minus 1 over x squared minus 9. I'm going to go ahead and factor this for you. This is going to be x minus 1. Just remember to know your factoring facts. X squared plus x plus 1 over x plus 3 over x minus 3. So p to the x is on top and q to the x is on the bottom, the denominator. The degree in the numerator is 3, and the degree in the denominator is 2, since n is equal to m plus 1, i.e. that 3 equals 2 plus 1. That means we have an oblique asymptote on step 6. I'm just letting you know here. And that means we're going to have to use long division on this one. We can look at the denominator and set this to 0 and find the domain. That means the domain is all real numbers, but x cannot be plus or minus 3. Because that would make it that you can't divide by 0. Also, this is already in reduced terms, so we don't need to do that. And that means we don't have a whole. And it also means we have a vertical asymptote at x equals plus or minus 3. Because these two always go together like that. Alright? Now, let's look at our intercepts. We're going to I'm going to write the equation again out. H of x equals x minus 1 times x squared plus x plus 1 over x minus 3 times x plus 3. Okay, so to find the x-intercept, we let this be 0. When you cross multiply, the denominator goes away, so we're basically setting 0 equals x minus 1 times x squared plus x plus 1. This part right here has no real zeros. It has complex zeros but not real ones, so we're only looking at this part. So when y is 0, x is going to be 1, because you have 1 equals x. You solve for that. So that's your x-intercept. The y-intercept, I'm going to go ahead and use the original equation. Makes it easier. Basically, we're going to evaluate when x is 0, what is y. So when x is 0, we got to find y. And what happens is, this is cubed, sorry. We're just going to get negative 1/9, which is actually 1/9. So we have two intercepts, an x-intercept and a y-intercept. Okay, we already found the vertical asymptotes. And now we know that the degree in the numerator is higher than the degree in the denominator. So what I'm going to do, let me write it down again, h of x equals x cubed minus 1 over x squared minus 9. We can't use synthetic on this because we don't have a linear term, so we have to use long division. So we're going to take x squared minus 9 and divide that into x cubed plus 0x squared. I'm doing placeholders here. And let's divide. And we're going to multiply x here. X, figure out the first one. So that's going to be x cubed. And then we have minus 9x here. And when you subtract, you're going to get 9x. Bring down the negative 1. So this is your remainder. You can write this as h of x equals x plus 9x minus 1 over x squared minus 9. This is insignificant. Remember that horizontal asymptotes are based on limits. So we do have an oblique asymptote. An oblique asymptote. So the oblique asymptote is at y equals x. Okay? We have to determine if we have any intersection points on the oblique asymptote. So basically, we know that y equals x, and we also have y equals x cubed minus 1 over x squared minus 9. So since they're both y's, we set them equals to each other and see if we can solve for x. And when I cross multiply, I'm going to get x cubed minus 1 equals x cubed minus 9x. The x cubes cancel, so x equals 1/9. So when x equals 1/9, what you need to do on this, since it does intersect the oblique asymptote, we're going to plug in 1/9 into our h of x. And you can work that out, and you're going to get 1/9 again. So that's where it intersects our oblique asymptote at y equals x. Okay? And these have to be the same if it has to, if it's going to intersect there. Okay. Now you can go ahead and put in the calculator. I'm going to go ahead and pick key points here at on the intervals. I'm going to go pick my intervals as negative infinity to negative 3, negative 3 to 1, 1 to 3, and 3 to infinity. So basically, the points I'm picking are negative 3, 1, and 3. Why? Because my vertical asymptotes are at x equals negative 3 and 3, and I also have an intercept at 1. And I want to know what's going on this portion of the graph and this portion of the graph. I also want to know what is happening between my X intercept. Okay, so now the points I'm going to pick are, let's see, I'm going to choose numbers in these intervals. So choose a number. I'm going to go ahead and pick negative 4. I'm going to pick 0 here. I'll go ahead and pick 2 here in between 1 and 3. And I will pick 4 here. Alright. Now, I'm going to evaluate these for the value of h. So we're going to do h of negative 4, h of 0, h of 2, and h of 4. So h of negative 4 is going to be negative 9.3. H of 0 is 1/9. H of 2 is negative 1.4. H of 4 is 9. Okay? And then location of the graph. Since y is negative, this is going to be below the x-axis. This is positive and this is positive, so these are going to be above. These are going to be below. I think we forgot to test the symmetry. There's no symmetry on this, so we'll just leave it as that. This is going to be below. And if you want, you can write down the points. The points will be -4, -9.3, 0, 1/9, 2, -1.4, and 4, 9. I'm just picking my x and my y. And then we graph it, which you probably already did. So I'm going to put my asymptotes, put them in. It's x equals -3. This is x equals 3. I'm going to go ahead and put in my slant. Some of you all know what a slant, but my oblique asymptote is y equals x. We know it does cross here. Do that as best as I can. Y equals x. Alright. And I have a y intercept at 0 and 1/9. I have an x intercept here at 0, 1, or 1, 0. Okay, so that's what I was wanting to see what's going on here. And then I have, I'm going on this side. When I did my intervals, I did -4, 9.3, which is kind of high. And it was below the graph. So it's in here somewhere. Let's make it about here. So basically what's happening is it's going this way. It's getting close to that and going down here. And similarly, I had 4 and I had 9. So it's way up in here. It's not symmetric. So basically what you're doing is you're kind of fitting it into our framework of our asymptotes, our slant one and our 2 vertical ones. Now where it crosses, where it crosses here is at -1/9, or not negative, but it crosses the y equals x at 1/9, 1/9. And I know here it's above the graph. So I'm going to graph it like this. And I know on this side it was below the graph. So it looks like that. Okay? So it does cross the y equals x axis, y equals x. Thank you and have a nice day. Bye-bye.